that. So let's talk about complex numbers. I think that everybody's already heard about the imaginaries, right? No? Haven't heard about imaginary? No. So we have this number system. Oh, that's weird looking. Where we have real numbers, and then we have imaginary numbers, right? Our real numbers are like our counting numbers.
Our rational numbers, our irrational numbers.
Zoe, what are the counting numbers?
1, 2, 3, 4.
That was kind of like. We'll wait for you.
1. Just count. You put canting, but it's counting.
What did I put?
Sorry about it.
No, I tried to put a U in there.
You put canting numbers.
I did it again, didn't I?
It says canting. Ah, Pedro. He spells country.
Okay. So let's talk about those counting numbers. Can you close that counting? Oh, that's not your laptop. That's a big old header. Counting numbers. What are the counting numbers? Exactly. It's the numbers that we count with, right? 1, 2, 3, 4, 5, 6. Those are called real numbers. Then there's the
Whole numbers.
there's a whole number.
0.
That starts with 0. So you got the counting, and you include 0 in there. That's also real numbers. So these are all real. Then we have this other set that somebody has called them imaginary numbers. And it's not really a good word because it implies that they're fake numbers and numbers that will never show up, but that's not necessarily true. Especially with the engineering and a lot of the new math and sciences that are coming out, that actually comes up a lot. Especially, like I said, in electronics, engineering. Imaginary is something that you're definitely going to want to know. We already talked about imaginary. You said imaginary numbers are what we label as, we usually label them as I, but I represents the square root of -1, right?
Yeah.
And that actually does come up a lot. We're going to encounter that sometimes. Last warning. Okay. So I, square root of -1 is going to come up sometimes, especially when we're working with quadratics that don't cross the x-axis. You're going to end up with roots that are what we call imaginary. Doesn't mean that they're not there. It's just that we're not going to see them on a 2D plane when we have x and y. Let's see here. If you have square root of -1 and you square that, so I squared, what does I squared become? Just using some simple math here. Not 1, -1, because the square is going to undo the square root, right? If we had I to the third, what's that going to become? Not -1. That's going to become negative I. A negative I. Okay, how did that happen? So let me show you how that happens.
Well, because they're still negative, because it like takes it out.
I to the third is I squared times I, right? Would you agree with that? I to the third is I squared times I. We already know that this piece is a -1, right? So what's -1 times I?
Oh, you see that? That's
Do you need to put the 1 up front?
No.
Not really. So you're going to get -I.
I just subtracted 2 from 3.
Cool. Let's go to the next level up. I to the fourth. What's I to the fourth going to be?
1.
That one is a positive 1. That's a positive 1. Reason being, I squared times I squared is going to be I to the fourth. And we already decided, or we figured out that I squared is a -1. So we're taking -1 times -1, and that just ends up being a positive 1. What do you think happens at I to the fifth?
Positive I.
Well, we already know 4 of them make 1. And if I have an extra 1, then that just becomes 1I. I'm just going to keep going here. What would be next? I to the sixth? Because I need you to see this. Let me go. Let's go I to the sixth. What's I to the sixth going to be?
Negative I times negative I.
Let me slow down for you guys here.
Negative I squared.
I to the sixth? Yeah, that's going to be a negative 1 again. This is how. I to the sixth is I to the fourth times I to the second, right? What's I to the fourth? 1. And what's I to the second? So what's 1 times negative 1?
Wait, but isn't it also I to the third times I to the third?
Say that one more time.
Isn't it also I to the third times I to the third?
Yeah, you could do that.
And then negative I times negative I is positive.
So if you did I to the third times I to the third, you said?
Yeah.
That would be negative I times negative I, right? Which would give you positive I squared. And what did we say I squared was? Boom. Oh, that's math. Okay. Can I get rid of this work here? Nope. Let's see if you guys can find, oops, I to the seventh.
I times negative 1. So it means negative I. And the negative I is
Negative I.
What is it?
Negative I.
negative I.
You're not Spanish? I mean, you're not Mexican, Steven?
There's no name is Chino. He's 100%.
I
don't know what happened.
What does Chino stand for?
Mexican.
Oh.
Mexican.
Oh. I thought it was Chino. Like,
You speak Mexican?
Yeah, his middle name is
It's
Chino.
real, that to go.
Leave that alone.
I said I have to go.
Where are you going? Oh, volleyball.
Yeah, I gotta go too.
Yeah, me too.
I'm the man.
Luis, what'd you get for I to the seventh? You don't know? So let's take a look here. We could break that up into I to the fourth and I to the third, right? What's I to the fourth? 1. So do I need this? Kind of, but not really, right? And then what's I to the third? Negative I. So I'm going to get negative I. How about I to the ocho?
1.
Yeah, it is 1. How do you know it's 1? I can't hear you with over all this talking. Go ahead.
You do I to the fourth times I to the second, and then that's just negative 1 times 1. No, sorry. Wait, I got it.
What if we did I to the fourth times I to the fourth? That would give me 8, right?
Yeah.
And then we know I to the fourth is
Yeah, that, yeah.
1 times 1, which is 1. Now what's happened at this point? If I went,
Pattern.
yeah, there's a pattern. Which ones do you need to know?
The first one.
Just the first 4, because after the first 4, they're just going to repeat over and over and over and over. You're going to get that same pattern. I, negative 1, negative I, positive 1. So, if I asked you to find I to the 27th, use that pattern. Find me I to the 27th, please.
Negative I.
Divisible by 3.
What is it?
Negative I.
No. Lucky.
Wait, can you go back to the other one? I forgot the pattern already.
Both.
It's I negative I 1 negative 1. Go back. I don't know. I forgot.
I, negative 1, negative I.
I negative 1 negative I 1. I negative 1. I'm guessing negative I. That's my guess.
Yeah, it's negative I. It's negative I.
I thought so. Maybe I should.
What'd you get, Luis? You don't like this? What's not to like?
Too much eyes.
Too much eyes?
Those too much ovos.
Jaylene, what do we know about every 4 eyes? What happens to every 4 eyes?
It's a 1.
Every 4 eyes goes back to a 1, correct? So, take a look at 27. How many 4s can I stuff into this bad boy?
8.
Hey, we get 6 of them, right? That would give me 6. That gives me 24, and I got a remainder of 3. That means I got 3 eyes left over. What did I to the third put me at? Negative I. Questions on that?
Where did you get the 4 from?
Where did I get the 4 from?
Because that's the pattern where it starts.
That's
I negative I.
Go ahead.
how many before the pattern resets?
I negative I.
This is pretty.
Did that make sense to you? So once I got to I to the 4th, what did it become? So if I had I to the 4th times like I to the 8th, I just got 1 times 1, which was 1 again, right? So every 4 i's, what do I have?
It repeats.
I just have 1. So what I'm looking for when we did this is we divided by 4. That means that there's 6 of those sets, which I don't care about, because that's just going to give me 1. And then I have 3 i's left over, which means that after 3 i's that are left over, I end up at negative I again. Because the pattern just repeats itself over and over, over and over again. Okay.
Can you do another one?
You want to do another one like that one?
156.
Okay, because you already know the answer. Do I to the 156.
What did you say? Every 4 eyes?
Every 4 i's
Negative I.
becomes 1. So if I have 8 i's, that's just 1. 12, 16, 20, 24,
39.
That's one.
That's not how far you go.
That's a one.
That's just 1 again?
Yeah, because you can do 12 and then 36 and 36.
Like
Oh,
that?
it's a 1.
And then 9 is
The I
1.
is 1.
So let's see here. So if I take 156 and I divide it by 4, I know it goes in here
39 times.
thrice. I get 12. 36 goes into 40. 4 goes into 36.
9 times.
How many times now?
9 times.
So that's going to give me 36. I have no remainder, which means there's no extra i's.
So it's a 1.
So that's just a 1. So that's just a 1. That makes sense? All we're doing is pulling 4s out of there. Because every 4 is just a 1. Okay? Alright, so this goes back to your question now. Those are imaginary numbers. Okay? What we're working with today, what are we working with?
Real and imaginary. Complex.
Complex numbers. Complex numbers. Please don't let complex numbers mess with you, because complex numbers are simply numbers that have a real part to it and an imaginary part to it.
So like a
Okay.
compound number.
Yeah, like a compound number kind of thing. But a complex number is composed of a real portion and an imaginary portion. Okay? So, go ahead.
3 plus 3i. That's a complex number.
Right, so 3 plus 3i is complex.
So it has a regular number and then imaginary.
Is this complex number?
No, that's a real number.
That's a real number.
So complex numbers and real numbers are not the same thing.
Is that a complex number?
No, that's an imaginary number.
No. Can I make this a complex number?
Yes.
How?
Adding up.
Add what?
Both
Add
34
I.
I can't add I, because I is square root of negative 1.
Add 34 eyes.
So how do I fix this?
5 plus 5.
That's a fantastic question. They might ask you to do that.
5 plus
I got a 5 that says it wants a complex answer.
Plus 5i.
I can't add 5i, because that's going to give me some weird number, isn't it? How many i's should I add?
4.
1.
No, because now that's changed my number, right? Stop and think about it for a second. Mathematically, what can I add to something so that I don't change it?
0.
So how many i's am I going to add to this to make it complex? Hold on, you just answered me. So, what can I add to a number so that I don't change it? 0. So if I have 5 and I want to make it a complex number, How many i's can I add to 5?
0,
I can add 0 i's, can't I? So now, that's a complex number.
That's a thing.
Yeah, that's a thing.
We didn't know that.
Well, that's why we're talking about it, right? That's why we're talking about it. So, if you get some kind of integer and they say, hey, write this as a complex form, then definitely add 0 i's. Did I add anything to that? No, but now I have a real part and I have an imaginary part. Okay? Same thing goes the other way. You know what? I ended up with 2i, but I need to write it as a complex number. How am I going to write that?
You said 0?
Exactly. Yeah, it'd be 0 plus 2i. And have I changed it? Not really. But now I have a position for the real part and I have a position for the imaginary parts. Does that make sense? See? Yes. Let's see here. What else we got to do? Oh, simplifying. Okay. Now, when we take the square root of a number, we're looking for a number that multiplies by itself and gives you the number inside, right? So like when we're looking for the square root of 9, the square root of 9, I know that that's 3 times 3, which gives me the 9, correct? So I say, oh, the square root of 9 is just going to be the 3. Because we really can't take the square root of a negative number, we kind of have to separate them, chunk them out. Does that make sense? So what I'm going to do is I'm going to break that apart. I know that that's the square root of 18 and the square root of negative 1. Because there's not really anything that I can do when there's a negative inside. So I'm going to break it up this way. Everyone's okay with that? What am I going to do with this square root of negative 1?
Throw it away.
Not throw it away. I'm going to give it a symbol.
I.
It's going to be what symbol? I. So, I. Now I need to simplify the square root of 18. And what we're going to do to do that, how are we going to simplify the square root of 18? We're going to do what's called prime factorization. Oh, we've done that. We did that at the beginning, didn't we? Now, I like to use upside down cake. Anybody use upside down cake? It's because I'm a big boy and I love cake. So I got 18. You see this inverse division thing? That's exactly what I'm doing. What's my smallest prime number that goes in here?
1 and 2.
2? 2 times 2 times 9 gives me that? Right?
Isn't 2 times 3 times
Now, I'm going to keep breaking this guy down. Can I divide this by 2?
No.
No, but I can divide it by 3, and that would give me a 3 outside, wouldn't it? And now I'm prime factored. How does that help me break down this root 18?
I have no idea.
Okay, because this is a square root meaning 2. Every 2 that are out here, I get to bring one out. So that becomes 3 radical 2.
Oh,
we
these
learned this
things.
in last year.
Yeah, I remember this.
Remember? Oh, no,
I just missed that too. Now, I want you to notice what I have here. I have 3 radical 2i. I really don't want you, because I make the mistake sometimes that I end up throwing that I inside, and that's just ridiculous. It shouldn't be that way. Because this is 3 radical 2 times I, I'm going to change this around to be 3i radical 2. And that way I know for a fact that my I is not inside the radical, it's outside of the radical. Questions on that?
So that's the answer?
Did I answer anything?
Is that just simple?
Yes, that is a simplified form. Good job. Questions from anyone?
Is it always going to be positive?
No.
There's gonna be 3s.
You can have negatives. Because if this is like the cube root, I can have negatives inside cube roots, right? It's just not in the square root, because in the square root, I need 2 numbers the same that multiply what's inside.
The positive times the negative.
But yeah, positive will give me positive. Negative gives me
Positive.
positive. I can't have a number where I go positive, negative gives me negative. Wait a minute. I said that wrong. Where positive, negative gives me positive. I didn't see her for a minute. I didn't see her go to the bathroom. Like from right here. Just cover your hook, you cover her up. There you go. Can I change the slide? I was.
Oh.
Like, where Justice go? And then I had to peek over and like, oh, okay. Like, I got 2 passes right here. Guys, if you need the bathroom pass, ask me please. I have them now.
Yeah,
And I'm gonna get the sign up sheet later on.
Ah.
I know.
Why do we have to sign out?
Because y'all just, like, I didn't mind people just going to the bathroom, but we want to keep a record of it.
It'd be taking too long.
Did you throw me a kiss? That was so sweet.
Why are you on a record of me questions?
Not of you necessarily, because, like, you don't really go a lot. But there's some people that are, like, they're like on a clockwork.
Hey, when you gotta go, you gotta
I
go.
just want to make sure people are okay.
Especially after lunch. That's what all
Oh, especially after lunch, you gotta go. You gotta go empty that bladder. All right, cool. How about you guys try this one? Simplify for me the square root of negative 12.
3 and 2.
3 and 2.
3 and 2.
5 and 6.
No, 2i3.
12 and 8.
9.
9 and 13.
4 and 8. 2i3. What are you talking about?
I don't know what you're talking about.
You can do 4 and 3, and then 4 is the square root, so you can be 2 on the outside, and it'd be 3 or whatever.
It's 2i3.
It's the opposite end of mine.
It's exactly the same but different.
Not bottom.
I gave it to him.
What did it be? 2 negative 3?
2 negative 3.
You wanna buy my week?
What's that Pac-Man from far away?
He was looking for like emojis.
Oh, probably
But it sucks when they get creased.
You can't tell.
I don't know why people get all upset about creasing their shoes. I'm like,
I know.
you're gonna like
Because-
flat
because-
feet.
Because then they don't look nice.
Who cares? That's what shoes are
You
for.
get all dirty.
I don't care.
No, I mean
First thing I do is like pop a squat, like break them in. Ah, on the phone.
yeah, but those are dress shoes.
I like my shoes. Yeah, you get a toothbrush.
Just don't get them dirty.
Don't get them creased. That's also gay. This kid's like, very, literally walking like this. You sure they're getting good? Like him and his friend.
Oh, that's you.
They were
This is like literally counting. These are just way different.
I don't know. Yeah, I don't like that.
Yeah, a little bit.
I mean, those are slow.
You should just do like, you really can tell that these are creased. The only thing that fits the symbol is this is that's what they crease. They're coming off.
See how I circle?
I only got 8%. No, so there was the 95, but it was a long and then it had the big question. They should rewrite all the way down. I want to get some of those, and I don't have any money, so I came with money. And then I put that
Your shoes don't have creases. Your shoes don't have
This is
creases.
their canvas.
My shoes don't have creases.
Okay, so no, like if you have like it's like a certain material, like I have yeah, that's why I can't wear it when I drive. I put my foot. Yeah, like yours have creases. Because you like move your foot, so like I never wear it because then they look so I don't wear it.
Thank you. Thank you, Murphy. You can put it on the shelf over there. You okay? There you go. I'll just have to be careful. I'll do the, what do they call it? The limbo.
Oh, I said Lumba.
The Lumba.
I said Limba and Zumba.
All right, thank you. So at the beginning, once I threw this one up, some people already saw that 12, well, this is going to become negative I, right? But then the 12, they split it up into 3 and 4. And that's okay too. If you can see that, yeah, because what's the square root of 4? It's just a 2, right? So this is an I, and that's a 2. That looks weird, so I'm just going to rewrite it as 2I radical 3. So if you want to go that way, that's just fine. if you want to do the upside down cake, we know we're taking 12 divided by 2 gives me 6. Divided by 2 gives me 3. I have 2 2's. So 2, radical 3 goes back inside. And then that I for that negative that's in there would look like that. Okay?
Wait, so how do you know which one to keep inside the radical?
Well, when you bring them out, they have to be in pairs. So I have 2 2's, right? So let me show you what I mean. You guys okay? Let me show you. Let me take, what do I want to do? Here's what I want to do.
Oh,
So let's say I had,
Negative 24.
54. Let's say I have 54. Okay? And I want to take the square root of 54. Here's what I'm going to do. Can I divide by 2? What would I get?
What?
27.
27. Can I divide by 2?
No.
No, but I can divide by 3. I would get 9, right? Then I would get 3 and 3. Because this is a square root, I need 2 of each. So I have 2 3's, right? Oh, what the? I think I just broke my smartboard. There we go. So I have 2 3's, right? Do I have any other pairs?
No.
There's no more pairs, right? So that means I'm going to bring out the 3,
And then
and what's going to go back inside?
6.
6. 2 times 3, which is 6. Okay? Ya, huevón, levanta la cabeza, cabrón. Levanta la cabeza acá.
I got a concussion yesterday.
¿Ya diste una concussion cup?
Concussion cup? Yeah,
Cálmate, cup.
Broca.
Te dio la boca cup.
No, it hit the side of my head.
But that one has the I.
Well, no, I was just kind of showing you how you break it down. But if there was a negative 54, if it was a negative 54, then yeah, you would have an I in there. Okay?
Is that how you know when to put the I? The inside?
Yeah, because you can't have the square root of a negative number, right? Okay.
Wait.
I don't know where that came from. What are you doing?
You only got 7 more minutes.
That's it? Why is time flying here? This is too much fun.
Oh, we have 7 minutes? I really thought we were doing it for like 30 minutes. No cap.
I hate math, but I have so much fun.
I hate math. I really do hate math.
You don't hate math.
I really do.
No, you don't.
There's some things in math that are fun, but other things are just like, why do I have to do this? This is so boring.
Yeah? Okay. Graphing complex numbers. Hey, before we do that, thank you. We're going to have to graph these complex numbers. But before we do that, I want to remind you of the old stuff we used to graph. Those, what are they called? Coordinate pairs. If I did 3, 4, how do I graph 3, 4?
Go right 3 up 4.
3 to the right from where?
That way.
From 0, 0, right? So 1, 2, 3. 1, 2, 3, 4. Then that would be 3, 4, right? Someone not understand? Someone want me to do another one? Okay, one more. Let's do negative 5, 2. If I did negative 5, 2, from the origin, 1, 2, 3, 4, 5, 1, 2, and then there's my point, correct? Okay. Now, we're going to be looking at a new coordinate plane, which is the imaginary plane. Okay. Now again, I don't know why we keep calling imaginaries. Whoever found the numbers, say that we can call imaginaries and whatever. You looked up, but no. That means I got 5 minutes. I only really need like 30 seconds because that's how good I am. What do we call this guy? X, and this one would be
Y.
now. Because we're going to be graphing complex numbers, this is going to be the real, and this one's going to be the imaginary, okay? So if we have something like 5 plus 2i, check it out. Don't look away, don't blink. 1, 2, 3, 4, 5. 1, 2. There it is. 5 on the real, up 2 on the imaginary.
That's it?
I just said it was going to take 3 seconds. if I had -2 minus I, 1, 2, 1. And there it is. Questions on how to graph complex numbers? Alrighty then.
You know, it took you 31 seconds.
I knew I should have changed my color.
We were actually counting.
Were you?
Yeah.
That's great.
You were close.